Today's OPT problem is a math problem, more specifically, a scientific notation problem. We'll start by figuring out exactly what the problem wants us to do, look at a few of the methods to solve the problem, then look at the incorrect answers to figure out why they're incorrect, how somebody could come to those answers as conclusions. The size of a particular grain of sand is 7.5 times 10 to the negative second millimeters. If a container has a size of 2.5 times 10 to the fourth millimeters, how many grains of this sand can fit in the container? Round to the nearest hundredth. The problem says that we have a container and we're trying to fit grains of sand inside this container. This is a classic division problem. The container is represented by 2.5 times 10 to the fourth millimeters, and the grains of sand represented by 7.5 times 10 to the negative second millimeters. Since we are trying to figure out how many of these will fit inside this, we will ultimately be doing 2.5 times 10 to the fourth divided by 7.5 times 10 to the negative second. Of course, they're both in millimeters, but when you divide two units of the same thing, they essentially cancel out. So from here on out, we will not worry about the units. On to our first method. As we already determined, we will be dividing 2.5 times 10 to the fourth by 7.5 times 10 to the negative second. This method takes a little longer, but it may be more simple. You need to change both of these numbers into their actual numbers. So we'll start with the 2.5 times 10 to the fourth. If the exponent on the 10 is a positive, that means the decimal for this needs to move to the right that many spaces. So we'll take the 2.5 and move the decimal 4 spaces to the right. We end up with 25,000 as our top number. Looking at 7.5 times 10 to the negative second. To change this scientific notation to its actual number, since this is negative, that means we move the decimal that many places to the left. So I will move this decimal 2 places to the left. And you ultimately end up with 0.075. If you divide these two, you end up with 333,333.3 repeating. To change this back to scientific notation, we have to have only one number in front of the decimal. Well, currently there's 1, 2, 3, 4, 5, 6. So we'll move the decimal 5 places to the left into this. Now the problem tells us that we need to be rounded to the hundredths place. So this is our hundredths place. This is a 3, so we'll round it down. So it will ultimately be 3.33. Remember before we moved the decimal 5 places? Well, that will become a positive 5 on the 10. Since it was a large number, this exponent is positive. If it had been a small number, anything less than 1, this number would have been negative. Now for our second method. Again, we know we are dividing 2.5 times 10 to the fourth by 7.5 times 10 to the negative second. What you may not know is that you can divide these numbers separately from the tens with the exponents. As you can see, I've separated the numbers from the tens with the exponents. 2.5 divided by 7.5 is 0.3 continuous. For this division problem, we need to understand our rules of exponents. When you have the same base, which is the 10, all you have to do when dividing, you subtract the top and the bottom. So it will be 4 minus negative 2. Division to subtraction. 4 minus negative 2 minus a negative becomes plus a positive. We end up with 10 to the 6th power. Our last step is to combine these two back together to make it look like scientific notation. I've now combined the two back together. I've taken the liberty of adding a few more 3's on that repeating 3 because we're going to have to round in the end, so might as well have a few extras so we can round correctly. There's an issue with this. While it is correct, we're supposed to have one number in front of the decimal. That's proper scientific notation. Right now, there are none. So I will move my decimal one to the right to make that true and change this into 3.3333. But if this number becomes bigger, which it did, it went from 0.3 to essentially 3.3, this has to get smaller. This gets bigger, this gets smaller by 1 unit on that 6. So it'll go down to 10 to the 5th. Remember, round to the hundredths place, which is this. This 3 rounds it down. We end up with 3.33 times 10 to the 5th. Now looking at our answer choices. We know that A is correct because that's the answer we got with both of our methods. B is incorrect. How could somebody come to B as a conclusion? Well, this person simply divided backwards. Instead of doing 2.5 times 10 to the 4th divided by 7.5 times 10 to the negative 2nd, they did it backwards. They did 7.5 times 10 to the negative 2nd divided by 2.5 times 10 to the 4th. This is wrong, but 7.5 divided by 2.5 is 3. Divide these two, which means subtract the negative 2 and the 4. You end up with negative 6. If somebody chose C as their answer, they just made a slight error. They did everything correctly, but they got a little confused on whether the exponent on the 10 should be positive or negative, and ultimately decided for it to be negative when it should be positive. A good way to help somebody not do that is for them to understand that when you have a large number, such as 333,333, the exponent on the 10 should be positive. If somebody were to choose D, they would have made the same mistake as B. They would have divided backwards. 7.5 times 10 to the negative 2nd divided by 2.5 times 10 to the 4th. Again, 7.5 divided by 2.5 is 3. But instead of subtracting these two, which is the proper rule for division, they added them instead and got 10 to the 2nd. So if they had chosen this answer, they would have A, did this backwards, and B, got a little confused on the rules for dividing exponents.